Welcome back to Up to the Time Technical Drawing Tutorials. Today, guys, we'll be going through hypo-cycloid. So far, we have done the cycloid construction and the epicycloid construction. Now we move on to the hypo-cycloid construction. But before we start, please take a moment to observe my screen layout. The left side of the screen is my AutoCAD screen that I'm working in, and the right side is the exercise that I'm actually pulling my information from. So I have it set up this way so that I can see the information that I need to plug into my AutoCAD. I would advise you guys to come up with a similar layout that's efficient, that would help you. Okay, so now I'm just going to maximize my problem. So this is what is given to me, where the base circle is 95 millimeters and the rolling circle is 20 millimeters, and these are both given in radii. The angle that we are going to set up this rolling stone to start at the base circle is 60 degrees, but we also need to find an angle called omega. Let's come into my AutoCAD screen and we can observe this formula here. The formula for finding omega angle. So you're probably wondering, where does omega angle go? So I'm just going to maximize now and just look at what I have over here. So omega angle is the angle in here that is between where we start our rolling circle and where we end our rolling circle. So just say if I were to grab a line and pull to here, the angle in between here is my omega angle, right? That's my omega angle. That would be in between there if I were to trim. This is my omega angle, but the angle that they tell us to start off is 60. So how do I find my omega angle? Come back here and I read the formula. The formula for finding omega angle, okay, is 360 degrees multiplied by the rolling circle diameter divided by the base circle diameter. So our rolling circle diameter is 40 and our base circle diameter is 190. So when I plug this formula in, I get something like 75.78 degrees. Now, all that means is that I'm going to add, if I want to find where this line is, I'm just going to add that 75.78 to 60 that we already have to start our problem. And that gives us a total of 135 degrees total. So from this line, which is our baseline, to the end of where the omega angle stops is 135 degrees. So let me just set that up over here now. So I'm going to remove all of my text and my information so that we can actually start this problem. So I'm going to insert my omega angle, which is 135. But if you know something about a straight line, and a straight line is 180 degrees, so if one side is 135 degrees, when we subtract 135 degrees from 180, which is actually what a straight line is, we get 45 degrees. So I can simply come here at this point and create a 45 degree line like that, right? And that takes care of my omega angle. I'm just going to put in the number in here so people at home following would understand what I did. Remove that. So I change the sign. The angle in here is 75.78. We'll just call it 75 degrees to keep things clean. But now what I'm saying is that these two angles combined, right? These two angles combined create 135. So put it here. 135 degrees is a combination of 60 plus 75. Just gonna just verify that on my calculator. 60 plus 75. Voila, 135. Now what I'm saying now on the other end is that if all the angles on a straight line must equal to 180 degrees, how much is this little piece here now that I'm going to insert? This little piece here is 45 degrees. So if you doubt me, you can add 45. You can grab your calculator. We can add 45 plus 75 plus 60. And we get 180, which is the angle on a straight line. So let us now start. Now that we have that there, we can actually start this demonstration. All right, so let us go. First thing, we need to divide this circle into 12 pieces. So that's div. You select the circle, type div to get your divide command. Select your circle, type in 12, and it goes like that. So circle has 12 pieces, and they are all marked on the circle so that we can see where we click into. And it snaps into those points as I'm hovering over them. So at this stage, I'm just dividing the circle, not too hard. And now what I'm going to do, I need to create a set of radial lines from this point here. So let's call this point here point C. So I'm just going to end text, create a point there, and call that point C. And just make sure that it's a capital C. And I'm going to create an mtext. Mtext is short for multi-text, guys. And that's B. And let's call this point here A, where the circle is going to start rolling. I'm just putting these in the correct layers. So all my text there. Yeah, so things don't look so big on the screen. All right, good now. I think this R is a bit too large, so I'm just going to. Oh, I can't do that. Oh well. I'll just take it out. And bring down that 135 degrees down to there. And just create a new circle. So there, yeah. It's a lot neater. Okay, cool. So what it is, I place all my angles inside the arcs. That's all, trying to make things a little neater as we progress. Now, what I'm going to do before I do anything, I'm going to number these points around the circle. So A is also positioned at point 12. So I'll just go here and I'll call that 1. So I usually copy all my numbers, and then I just go back and edit later on. I find that this is faster than yeah. Okay, that's 1. Just need to go to 2 now. 2, 3, 4, 5, 6. So one thing is, you guys should always remember that the circle must be divided into 12 pieces. How do you remember that? A clock has 12 points. So if you think of a clock, you can always remember that the circle must be divided into 12 segments. And A is going to be A comma 12. Let's call it. No, you know what? Just leave it as A, and let me just bring one of these letters, numbers there. to represent the 12 point. So A and point 12 share the same point. Okay, good now. We now need to create radial arc lines at each of these divisions. But seeing that these divisions are going to line up with each other, we only got to really and truly make arc lines at half of these divisions. So it's only at 6 points. So let me explain. 6 is a standalone point. However, 7 and 5 go together once we pull our circles from point C, birthing them at point C. 4 and 8 go together. 3 and 9 go together. 2 and 10 go together. 1 and 11 go together, and 12 stands alone there, which is our the base that the rolling circle would roll on. Okay, so before we go any further, let's just trim and keep things neat, because we don't need all these lines and we don't need all of these lines. And oops, can be deleted. So we only got what we need. We can even trim again, because we don't need, only need, actually, let's just trim here. I don't want to go ahead of myself and trim things that I might need later on. Okay, I think that looks good. That's the path. That's the path there. But first, this is a very important thing we need to put in. I'm going to go over to my hidden layer, and I'm going to create a circle that actually lines up with the axis of the rolling circle. Alright, good, because that is where that's the axis. So I need to put in my axis point, or my axis line, and I have trimmed that. Good. Now, what am I going to do on this axis line? I'm going to divide that axis line into 12 segments. Let's proceed. Div is the command, short for divide. Select the line, type 12, and we get 12 pieces. Now, I'm going to head back over to my construction layer, and I am going to start pulling each piece down to the center, or to point C. From each point, I'm going to make the connection to point C. And I'm also going to number those points too after I finish this this part here of the drawing. Some people actually do this problem only using half the circle. So they would trim like from 12 all the way down to 6 and only use the half, 12, 11, 10, 9, 8, 7, and 6, whereas the half that has 5, 4, 3, 2, and 1 is gone. Because seeing that some points share 2, these are share 2 points, 10 and 2, you only effectively just need half the circle. You don't need the other half there because they're sharing, so they can actually be removed. So it's to make things less complicated. Now, I think I'm going to do that at this stage now, because I'm going to put some numbers in here, and I really don't want to confuse my viewers. Should I not? I can probably trim that at the end. That's what I'm going to do. Okay, so let me get to the numbers. That's my 0. Let's start here with 1. 1, and you know the drill. I'm going to copy 1 and stamp it in at each point, and then come back and change. Two, 3, 4, 5, 6, 7, 8, 9, 10. And after this process, I'm going to extend these same lines to touch the base circle. So I'm going to extend these lines here to touch the base circle. So to do that, I use the command extend, EX, to access extend, enter, select all of these lines here, select my base line, and then just go back over them like that, and voila, we have an extension. Cool. Now I'm thinking that it's best to only use half of my circle so that I won't confuse this demonstration. So I'm going to remove some of these pieces here. So I'm going to trim this circle. So let me just clean up these things. I'm going to pull these points back to there, to the axis. I'm just doing this so that no one actually gets confused. You can actually see things clearly. Because there are many lines on the screen. I wouldn't want to confuse anyone. If you don't need the full circle, you can just use half of the circle to do the demonstration. I mean, I can always put back the circle at the end if it helps people. And I'm going to put the circle, or sorry, the semicircle now in outline layer. Cool. Let me just put things in the proper layers now before we go any further. So we got like one more step before this problem is finished. I have to roll the circle. I have to roll the circle from this is point 0 all the way to point 12, and then plot the course. So we are doing an epicycloid, and that means I'm going to create a circle now on my outline layer, and I'm going to create a circle at point 1, and my circle is radius 20. I remember that. I'm going to track that point there. Okay, so my first point is right here at A. A is my first point. I'm going to change that over to, let's just use dimension. No, let's use the text there. So I'm going to be plotting my points on the text there. Now, where is my second point? Let me just move this A above here so that it isn't in the way. That's my first point here. My second point is the circle interacting the second line above or below the baseline. So right here, somewhere along here is my second point. Let me just place a point there. Yep, intersection. So now I'm going to roll the circle. So I'm going to move it. The term rolling means moving the circle from 1 to 2, or from 1 all the way down to 12. So I'm going to move it at 2, and then let's see the intersection. Intersection I'm looking for is the circle intersecting line 6. Not 6, line 10, sorry. Which is right there. Actually, I don't want to. I want to be placing my points on one layer. Let me just clean that up. Okay, good to go now. So that's the second point. Now I go over to the third point. So I'm rolling the circle and I'm looking for the intersection 9 and right here at the circle. Cool. Find the intersection, move over from 3 to 4, and intersection Then the circle intersects line 8. Cool. Moving the circle from 4 to 5. You're looking for the intersection at line 7. Moving from line 0.5 to 0.6. And we're looking for the intersection at line 6. So 6 and 6 line up. There. And we're going down the line, moving from 6 to 7. And this is where we now look at the intersection at 7. So 7 and 7 line up. And we're going down, move from 7 to 8. And 8 and line 8 line up. The intersection is right here. You can see it. We move from 8 down to 9. And the intersection at line 9 as it intersects with the circle is right here. Then we go 10, intersects line 10 right there. And what about 11? 11 and line 11, this is line 11. And then the circle is at 11, it's right there. Right. And I know where the last point is going to be. The last point is on B. Let me just move B slightly out of the way. Let me place a point there. Okay. So I have all my points in. Now it's time for me to plot this. So I think it's best for me to get on to the outline layer and turn off my construction lines. Turn off my construction lines. Yeah, I can see my points. And I'm going to use spline. Sorry, spline. S-P-L-I-N-E. That's the command I'm going to use to connect these dots. And this is basically it. Once I've finished here, I've done the hypo-cycloid. And I've done the epicycloid and the normal cycloid. Alright, so that is what it would look like. So let me just, you know what, let me just let it rest, insert the rolling circle, rest at 0.6. I think it looks cool there. Alright, looks like an eye, yeah. Now I'm going to turn on my construction so that you guys can see the finished thing. I'm going to take off my construction. You guys can see it. Yeah. So I'm going to place all this now into my frame, my title block. I'm going to put the title Hypo-cycloid, Hypo-cycloid, Hypo-cycloid. I'm going to adjust the phi by placing in the middle center and C, close, and I'm going to put it onto my, okay, I didn't want to do that. I'm going to put it onto my text there. Good. I think it's a bit small there, so I'm going to increase the size. Let's say 10. Whoa, good. That's nice and big. I'm going to turn off my point style. Put them now to, it's not 2. Yeah. So that's a finished demonstration there. This is what we started started with this diagram, and we actually ended by placing the hypocycloid. And what is the hypocycloid? The hypocycloid is actually the curve that is created when this rolling circle rolls on this base circle and it moves from point A to point B. This is the curve created, and it's called a hypocycloid. So we have done the hypocycloid, and we have done the epicycloid, and we have also done normal cycloid. Thanks for watching, guys. I hope you learned something. Please like, share, and subscribe to the channel to see more interesting demonstrations. Thank you.